Factoring a perfect square trinomial. So for example, we're given a squared plus 12a plus 36. Notice factors of our AC of 36 that add to equal 12 would be 6 and 6. So we get a squared plus 6a plus 6a plus 36. Group in pairs of 2. Pull out the common of a. So I'm left with a plus 6. Pull out the common of 6, and I'm left with a plus 6 again. So notice what's inside that we pull out front matches what's pulled out that becomes our second term. So these are identical. Another way of writing that is that we have two a plus 6 terms. This is called a perfect square trinomial. It comes out to be the same factor twice. Another example would be 16x squared minus 56xy plus 49y squared. So factors of 16 times 49, which is 784, that add to equal 56. Well, let's start trying a couple. If we divide by 4, we get 196. If we divide by 21 doesn't work, 22 doesn't work. So this is where I'm trying to show you that trial and error is sometimes something you'll have to do. 28 and 28 are an option. And that means if I have two negatives, they'll times equal a positive but add to equal a negative 56. So I have 16x squared minus 28xy minus 28xy plus 49y squared. Grouping. What's common that I can pull out of the front one? A 4x, leaving me with 4x minus 7y. Pull out a negative 7y, and I get 4x minus 7y. So once again, what's inside matches what I pulled out front. And since I have two identical terms, I have 4x minus 7y squared. Let's do one last example. Say I was given y squared minus 16y plus 64 minus z squared. So actually right now as it is, I can't factor this because of these four terms. There's nothing common. If I start grouping, you realize very quickly you can't get the same pairs. But if I just focus on this piece for a second, factors of 64 that add to equal negative 16 are negative 8 and negative 8. So in here I'm going to have y squared minus 8y plus 64 minus z squared. So that's just going to be kept outside. Group in pairs of 2. So they have a y in common, so I get y minus 8. Pull out a negative 8, and I get y minus 8 minus z squared. So since they share that in common, I have y minus 8. What I pulled out is another y minus 8, and I still have minus z squared outside. So instead of two same piece, I can rewrite it to say y minus 8 squared minus z squared. And we're not done, because notice I have a difference of two things that are being squared. So I can factor it as the first minus the second, the first plus the second, and it's factored.